And there we go. Thank you so much, everybody, for joining in this Thursday, March 25th, 2021. My name is Adrian Kosmaczewski. I'm Developer Relations at Vision, and I have the privilege and the pleasure to introduce to you this episode one of this webinar series about GitOps, proposed by Bespinian and Vision. And speaking about Bespinian, I would like to introduce you to Mathis Kretz and Lena Fuhrimann, who will be doing the talk today. I'm just here to say hi and to moderate your questions. Speaking about which, there's a small Q&A box if you're using the Zoom client. I think in the web client is available as well. And of course, any questions you might have during the event, I will forward them directly to both Lena and Mathis. They will decide whether to reply to those questions during their presentations or afterwards. But in any case, make sure that we are very, very happy that you're here, and we would like to, of course, be able to answer all of your questions. So without any further ado, I give you Lena Fuhrimann from Bespinian, who will start the presentation tonight. Thank you so much. Lena, I'm going to stop sharing and the stage is yours.
Thanks, Adrian. So I'll share my screen. Should now be able to see it. And you should see the slides. Is that working?
It's working perfectly well, thanks.
Great, okay, thank you. So welcome, future friends and friends, to this first webinar in our series about Git and GitOps. We are a bunch of engineers from Bespinian and Vision, as Adrian already said, and we are passionate about automation and using Git to keep track of changes in our environments. And in this webinar series, we would like to talk about different concepts around Git and GitOps. And on the first part, we will look at Git itself and what is important about it when using it in a team. Then the second webinar will be about infrastructure as code, which is a handy concept which helps to unify different environments and be aware of the exact changes made to different parts of your infrastructure. And then in the third and last part, we will combine these ideas and delve into the concept of GitOps. And following these principles can help you and your team to improve the communication, investigate issues more easily, and work more efficiently in general. But be aware that there are also several caveats when adapting such new ideas and technologies. That is why we will also look into some common pitfalls and speak about our past experience getting teams started with such tools. And as Adrian already mentioned, if at any time you have questions, just write them into the Q&A chat window, and we will try to address them right away. Let's start by looking into what Git is and how it works. Git is a very common version control system that has evolved into one of the standard tools for modern software development. And it helps us to keep track of changes to all of our source code. When collaborating in a team, for example, it lets each developer work on their own feature on a separate copy of the code without getting into each other's way. Furthermore, Git allows us to easily travel the history of our source code and understand changes by looking at the order they were made in and read the small pieces of documentation their authors have left us. This is hugely helpful when debugging code other people have written, or even code that I have written myself some time ago. So I can always jump around different points in time, see individual changes, and even revert them to create new fixed releases. And we may take much of this for granted, but think about how finicky working with code in a big team would be without these features. As many of you know, in Git, developers make changes to source code in the form of so-called commits. And a commit is a small set of changes to one or multiple files, and it contains information about the author and the time the changes were made. And in order to be able to understand these changes, the developers are asked to document their commits with small pieces of text, which are called commit messages. And the quality of these is a vital part of the health of our code base. Making good commit messages helps our teammates and also future selves to understand the purpose of changes and the specific ways of implementation. And if done well, they provide crucial information at a glance and are structured in a way that lets us browse and even search the history of the code changes in our code base. First, let's talk a bit about bad commit messages and why they are bad. Then we will look into how to improve them. So the worst commit message is obviously an inexistent one. Not adding a message to our commit is luckily considered bad practice by most engineers because it gives someone who browses our changes no context at all, and it leaves them to figure out the effect and purpose of our changes by themselves. It also doesn't make developers think about their changes and why they are making them in a certain way. And we think that this process is hugely important because it helps developers make more conscious and focused changes. A meaningless commit message like did some stuff, now it works, is clearly not much more helpful than not having a commit message at all. Another indicator of a very bad commit message is if you have a long commit message that contains the word and one or even multiple times. First of all, long commit messages aren't easy to read and comprehend. Secondly, they strongly suggest that too many unrelated changes were crammed into a single commit. Such commits are hard to understand and manage and should be omitted. It is much easier to understand a set of smaller changes with a clear history documented in their individual messages than one huge commit which contains multiple unrelated changes. Good commit messages, on the other hand, are clear and concise. They describe what the changes of the commit do in a human readable way and do not contain any superfluous punctuation or words. Good examples here are upgrade Lodash dependency, or fix typo in README, or return correct error codes for all errors. These examples can easily be read and understood without knowing the context of the whole application. So in summary, the most important rule about good commit messages is to write them at all and to write them in a concise format that can easily be understood by our future self and others. Excuse me. So far, we have only talked about the subject of a commit message, which is the first line. And most people use only the subject line to describe their change in most cases, which is sufficiently for almost any commit. If, however, a commit is a bit more involved, or the changes and the rationale behind them cannot be easily understood, then it can be helpful to explain the commit in a more verbose form. And that is what the body of a commit message is for. Here you can see an example of a commit message containing a concise subject line, namely return correct error codes for all errors, and a body that explains it further. As you can see, the body is separated from the first line by a blank one, and it is written in proper language to make it easily readable for our peers. It is mostly used to explain why a commit was made. If necessary, it can also be used to explain the changes themselves in a more explicit way if they cannot be understood intuitively otherwise. So, in order to write proper commit messages, as we saw, there are a few guidelines to follow. And we try to boil these down into 7 important points. These will help us to standardize the formatting of commits within our teams and to follow the guidelines that Git itself abides to when making commits. And that happens, for example, when it makes a merge commit. So let's look at these 7 points. Firstly, we should separate the subject line from the body with a blank line, as we saw before. Of course, only if there is a body at all. This helps Git tooling to parse the commit message correctly, and for human eyes to quickly see that there is actually a subject line and a separate body. which helps us to further understand the rationale behind the commit. The second point is that it is helpful to limit the subject line to around 50 characters. This is first and foremost a guide to keeping our messages concise and letting people browse them more easily when reading a list of commits, for example, to find the right one. But it also makes sense because much of the Git tooling out there cannot show an unlimited amount of characters when displaying commit messages, because usually the screen estate is just limited. The third good practice is to capitalize the subject line of a Git commit message. That makes it easier for people to see where it starts and to read, because it just feels more natural to us. The fourth guideline is that using punctuation in a Git commit message just unnecessarily makes it longer. And mostly commit messages are not proper sentences and don't deserve a period or an exclamation mark at the end anyways. The fifth guideline is an important one. It is to use the imperative mood when writing them. What this means is that you should write your messages in the present tense, and that you should make them sound like an order. A good way of checking if your message follows this guideline is to think the sentence, if applied, my commit will, and then appending your commit message. And if that creates a sentence of proper English, you most likely used the imperative mood correctly. Again, we use the imperative mood because Git itself uses it, and to make our messages more concise. There are also certain guidelines for the message body, if you use one at all. So number 6, the body should be wrapped at around 72 characters. The reason behind this is that human eyes cannot or can most easily process text at that width. Since the body can contain long sentences of prose, it is helpful for readers to have the width limited to that amount. So it is not necessarily due to legacy terminals being small and only being able to display 72 characters. It's really for our readers. So I think this point is still relevant in the modern days where we have huge screens, but still it's easier for people to read like that. Then the last and 7th good practice is to use the body to further explain the what and why of our changes. It should help a reader understand what changes were made and the reasoning behind the changes. It should, however, not explain the code itself and tell the reader how the changes were made or how a certain problem was solved, because that is what code comments or actually intuitively written code is for. Another important part about Git are branches. I'm sure you've all heard of them or used them, maybe to hold a specific feature that isn't ready yet, or just to try something out. When working in a team, it is important to adhere to a branching strategy that everyone agreed upon. Depending on the size of your team and the complexity of the application it develops and releases, different ways of using Git can make sense. In the following, we'll have a look at 2 of the most common branching strategies and when they make sense. The first strategy is called Git flow. It allows to easily collaborate and work on multiple features at a time. The core of Git flow is the so-called develop branch, indicated here in purple. That is where all the work happens. To create a new feature, for example, developers create a feature branch, marked here in green, and in the picture, and they branch it off the develop branch. Then they create one or multiple commits on that feature branch until they are happy with their changes and think that the feature is fully implemented and hopefully also tested. Then once that is done, they create a so-called pull request. That means that they open up their changes for review by their peers before it finally gets merged back into the develop branch. This means that the develop branch should always be in a healthy and deployable state, and that feature branches are short-lived because they get deleted once the specific feature is merged. The second important branch in Git flow is the master or main branch. It is here highlighted in blue. It contains only code that has already been released. So it ideally contains one commit per release, and the commits are tagged with the respective release number, as you can see here. So that means that the master or main branch should always remain stable and releasable. But how do commits get from the develop to the main branch? So once the developed branch is ready to be released, a new release branch, highlighted here in the teal color, is created off the develop branch, where all of the commits that should be part of the specific release are collected. This can happen by completely releasing the develop branch as is, or by cherry picking certain commits from develop into the release. Once the release is ready, the respective branch gets merged into the master branch and properly tagged as a clean release, and then merged back into develop. And by doing so, we can make sure that there are no changes on the master branch which aren't already on the develop branch. Now, obviously, it can happen that we create a buggy release. For that case, Git flow introduces the concept of a hotfix branch. In the picture, we used red for those, or orange. We branched these off the master branch, make our necessary fixes, and then merge the hotfix branch back into the master branch, but also into develop. And then with the new master branch containing these changes and fixes, we can create a new release, which now contains the hotfix. So in summary, we have the two main branches, master and develop. And by creating feature and release and hotfix branches, we implement new features and hotfixes and merge them between the two main branches. This makes Git flow quite structured and flexible. However, it introduces some overhead, which can especially be a lot of unnecessary strain for smaller teams. But for larger and well-established teams, it can bring great value and structure to ease the communication and also the collaboration within these teams. Another big advantage of Git flow is that there is quite a lot of tooling around it. One of them is the Git flow plugin for the Git CLI itself, which adds handy commands for working with Git flow. Let's have a look at how that looks in practice. So here, first, I will just create a new MD directory called Git flow example, and then I'll enter that. And now, instead of just typing git init to initialize the Git repo, I can type git flow init once I have this plugin installed. The plugin will then ask me what are the naming conventions in my team for different branch names. Usually it's good to just accept the defaults here. One exception might be the master branch, because there have been changes in the Git community lately because the word master is politically a bit heavy. So people nowadays tend to rename their master branches to main sometimes. Other than that, we're just, other than that, we're just gonna accept the defaults. And this leaves us with an initialized Git flow repository. So now we can start our first feature branch. And for that, Git flow has the command git flow feature start, and then the name of the feature. In this case, it's called kitten. Now you see Git flow tells us what it did. So it created a new feature branch called feature/kitten, and it switched to this new feature branch for us. Now here I can make my changes that are necessary for the feature to be implemented. For example, I will add a new file called kitten.txt with the name of my kitty. Now I will commit that. By the way, if you don't specify the -m flag when you do a git commit, then Git will automatically open your favorite text editor for you, which is quite handy. Now I'll give it a proper commit message. And commit. So now once I'm done with my feature, I can just type git flow feature finish. This will merge my feature branch back into develop and delete it because it's no longer needed. And the witted among you might have noticed that we skipped the step of a pull request here, but that is just because we're such badass engineers and obviously never make mistakes. Now, out of our awesome feature, we want to create a new release. For that, again, I can just type git flow release start and then give it the name of the release. In this case, I think our application is ready to be released as version 1.0.0. Again, here I can make changes. For example, add a version file, commit those, give it a proper commit message. And now I can finish the release by typing git flow release finish. This will ask me for a commit message. I'll just accept the default one. And it allows me also to document the Git tag that is being created with, for example, a changelog or with the description of my new feature that I want to, or sorry, with the description of my new release, so what it should contain. Here, I will just type a simple message and commit everything. So now, if we look at the log of our changes, we see that we have quite a linear Git change history, and with clean commit messages, and also some of them even contain a body, namely the one that created our release. Next, we will look at another branching strategy, which is called GitHub flow. In contrast to Git flow, it only contains a single main branch, which is mostly just called master or main. So we're missing the develop branch here in contrast to Git flow. And everything branches off this main branch. So the main branch is used as the working tree to branch features off. And then the releasing of software is also done on that single branch. So we just tag commits on that single branch. And this enforces a strictly linear development process because one can only go forward and not cherry pick specific changes from one branch to another. So history is very linear. While this may be seen as a restriction by some developers, it can also be a great advantage because it makes it clear what is released where and which sets of features belong together and into a release. So people can view at a glance what features are included in which release and know how the individual releases differ. This makes the workflow simpler and less error prone, but also a bit less flexible than Git flow. So GitHub flow is a bit more suited for smaller, more agile teams and projects that release often and want to keep a simple workflow. Now I'll hand over to Tis to delve more into merging strategies.
Thank you, Lena. I will take over the screen share. Can everybody see what I'm sharing?
Yes, perfectly well.
Thank you very much. So next, we want to look at how we can bring changes from one branch to another. In Git, there are two main ways of doing so. There is merging and there is rebasing. For both of them, we can start with the following example setup, which you can see at the top half of the picture. So let's assume that we have a branch named master and a branch named topic, which branches off from master at a certain commit E, and which makes commits A, B, and C on top of E. In the meantime, the master branch has also evolved, and it's evolved further from commit E with commits F and G. Now let's assume we want to bring the changes from topic back to master. If we do this using the mechanism of merging, then all changes from the topic branch are integrated into the master branch in a single new commit H. This new commit is commonly referred to as the merge commit. In the best case, the commits F and G, which have happened on the master branch in the meantime, have only touched parts of files which are not overlapping any parts of files which were touched by the commits A, B, and C on the topic branch. In this case, the merge is executed automatically by Git. In the worst case, however, the commits on the topic branch have touched parts in files which were also touched by the commits on the master branch. This is the dreaded merge conflict. In this case, the person who is performing the merge is prompted to manually merge the changes in the conflicted files. Merge conflicts are how Git resolves the fundamental problem of several people concurrently working on the same set of files. It is fairly normal that they happen occasionally. However, if you have frequent merge conflicts in your project, this is usually an indication that something is not right. Either your team might be trying to implement things which somehow contradict each other, or parts of your architecture are overloaded because every change somehow needs to touch them, or people are not communicating well on who is doing what at which point in time. So it's obviously always a good idea to reflect why a particular merge conflict is happening. Merging has the following properties to keep in mind when we compare it to rebasing. Merging is very explicit with respect to who performed a merge operation at what point in time. Since a merge is not rewriting any commit history, but actually only adding one new commit to the target branch, it is also safer to use on branches where lots of people are making concurrent changes. The other way of bringing changes from the topic branch back to the master branch is using the mechanism of rebasing. Let's use the same example setting as before, which you can again see at the top half of the picture. So rebasing the topic branch on the master branch means that we replay all commits from the master branch on the topic branch. In the case of our example, this would mean applying commit F on the topic branch and then applying commit G. As we replay each individual commit, merging can either be done by Git automatically, or a conflict arises, which then has to be resolved by a human. The end result of rebasing the topic branch on the master branch is that the topic branch now contains the commits F and G, plus the commits A, B, and C, potentially modified during merge conflict resolution, which is why we call them A prime, B prime, and C prime in the picture. Rebasing has the following advantages. Since the commits from the source branch are sequentially reapplied to the target branch, the resulting commit history becomes a lot cleaner and a lot easier for humans to read and understand. When rebasing, there are no merge commits cluttering up your history and talking about branches which no longer exist. Next, we will have a look at pull requests, sometimes also referred to as merge requests, depending on which platform you're hosting your Git repos on. Indeed, pull requests themselves are not part of Git, but they are featured in all major Git platforms, like, for example, GitHub, GitLab, or Bitbucket. Pull requests are an important tool for collaborating on Git repos and for properly implementing the branching strategies which were mentioned earlier. So let's assume that you have implemented a new feature on a feature branch according to Git flow. First, we want to have a look at some good practices when submitting a pull request for your feature branch. Following these practices will make your reviewers' life easier, which in turn will help you get the most out of their review. The first good practice you should follow is making sure that your feature branch is up to date with the latest changes on the master branch. Sorry, on the target branch. After all, you want to make sure that your change works on the current version of develop and not just on a version from way back in time when you branched off your feature branch. Furthermore, you don't want to place the burden of closing this potential gap on your reviewers. So according to what we discussed earlier, you would now rebase your feature branch on the latest develop branch, meaning that you sequentially apply all commits that have happened on develop since the point in time when you created the feature branch. Let's have a look at how that works in practice. Let me switch to the terminal. All right, so we are here working on a feature Saturn to Neptune. Let's have a look at the commit history in our repo currently. And this is how it looks like. So we have a bunch of commits, each commit adding information on a different planet. And as you can see, there is a feature branch happening at the commit which added information on the planet Earth. And the feature branch adds information on the planet Saturn, the planet Uranus, and the planet Neptune. In the meantime, develop has also evolved further. So on develop, we can see additional commits for the planet Mars and for the planet Jupiter. Now, obviously, before submitting our feature branch for review, we want to make sure that our feature branch is brought up to date with those two commits on develop. So this we do by rebasing our feature branch on develop. So we hit git rebase develop. That luckily happens without merge conflicts. And now we can see at the updated Git history, and you can see that our local copy of the feature branch is now updated with the commits adding information on the planet Mars and adding information on the planet Jupiter. However, obviously the remote version of our feature branch does not yet have this these commits integrated. So we do this, we correct the situation by issuing a push command with the -force flag. We can do this because we're working on a feature branch where we're working alone. So it's okay to change the history there. Let's have a look at the history again. And as you can see now, we have a nice and clean linear history on our feature branch, which has been updated by those two commits from develop. So we're now ready to submit our feature branch for review. The next good practice you should follow before submitting a merge request is to review the diff which results from your changes. When doing so, you should check that you're only submitting changes which concern the feature you're building. You should take care not to mix these changes with unrelated ones, say dependency updates or code formatting, which will make it much harder for the reviewers to understand what's going on. If it's not possible to separate the relevant from the unrelated changes, this tends to be a clear sign that you're overloading a pull request. Another practice is cleaning up the commit history of the feature branch. Your reviewers should be able to use the commit history to help them understand the reasons for specific changes. Therefore, your feature branch should not contain commits which resulted from trial and error and from changes which were made irrelevant by later commits. But how can we clean up the history in hindsight, you might be asking? Once again, the rebase command comes in handy, this time rebasing the feature branch on itself. Let's switch again to the terminal and see how that works. So let's again have a look at our history where we left off last time. As you can see, we have a nice and clean, updated commit history on our feature branch. But what we can spot is that there are 3 commits regarding the planet Saturn. One is adding information on the planet Saturn, and then it seems that we made some trial and error. So the next commit after that adds some more information on Saturn that we had forgotten, and the next one removed some wrong information about the planet Saturn. So it would seem that if we wanted to submit this feature branch for review, we might want to remove this this history of our trial and error, and basically squash all of these 3 commits into one commit, adding information on the planet Saturn. We can do this by issuing, again, the git rebase command, in this case with the -i option for interactive, and we want to rebase the whole history, so we specify --root. What this does is it starts our favorite editor, shows us the commit history, and allows us to specify which commits we want to change in hindsight. And what we're going to do here is we are going to squash those 2 bad commits, or those 2 commits we don't want to see in the history anymore, into the commit right above them. So we're just going to say, please squash all of the changes in those 2 commits into the commit adding information on the planet Saturn. If we hit save here in our editor, Git goes ahead and asks us one more question, namely what to do with the commit messages of those 2 commits. So here we're deciding to just use the commit message of the original commit adding information on planet Saturn, and to discard the other 2 commit messages entirely. We go ahead with that, and if we look at the commit history right now, you can see that again on our local copy of the feature branch, we now have only 1 commit on the planet Saturn, and we need to propagate this again to our remote copy, which we do by issuing git push -force again. And then we can check our history again and see that we now have an even cleaner history to pass on to our reviewers, which no longer features those 2 trial and error commits, but 1 clean commit add information on the planet Saturn. So we're definitely ready now to hand this to our reviewers. The last good practice to follow is a very simple one. Write a clear and concise title and description so that your reviewers immediately know the context in which you're proposing the changes. In a sense, the same rules that we have seen for single commit messages also apply here. Say in a human readable way why you're doing something. Additionally, it sometimes makes sense to add instructions for the reviewers which will guide them in reading and understanding your changes, i.e. things like you should start by looking at the changes in awesome.go and work your way in from that file. So now that we know how to submit a pull request, let's also have a look at how to review one. Wrapping your head around someone else's work can be quite daunting. A good way to achieve this is by mentally sketching your own solution to the problem at hand before starting the review. You can then use your mental sketch to guide you through the review and check for specific changes which you would expect to see or not expect to see. For example, when reviewing a pull request described as allow users to enter their birthday in their profile, your mental sketch would probably include the profile screen receiving a new date chooser, the profile API receiving a new date field, and the profile database receiving a new, the profile database table receiving a new date column. Seeing a change in the shopping cart API, however, would be unexpected and would probably lead you to ask the author for an explanation. Apart from having a mental sketch of the expected solution, there are a number of further guidelines you should stick to when reviewing a pull request. The first one is a pretty obvious one: be constructive. For every problem you spot, you should not just point out that problem, but you should have a better solution ready to propose to the author. Also, you should always remember that you're reviewing code and not the person who wrote it. Hence, your comments should address weaknesses in the code and not weaknesses in the author. The second guideline is don't just be a linter. The whole point of reviews is that they're performed by fellow humans who know the semantics of the problem at hand, the architecture of the system, and the design decisions that were taken to build it. So expect to dive into the code. Spending your time on correcting, say, indentation errors would be a waste. Indeed, the latter can even be done automatically by introducing automated linting. The third guideline is also review what isn't there. It often comes naturally to just look at the code changes which the author of a pull request is actually proposing. However, that is usually not enough. Indeed, you will also have to think about what is missing. This is where your mental sketch again comes in handy. Are there any changes which you would have expected to see but you're not seeing? What about tests? Are there any test cases that the author has forgotten, indicating that some boundary conditions might be forgotten? The last guideline is that reviews are performed interactively between the author and the reviewer whenever a pull request exceeds a certain complexity. Pairing up and having synchronous conversations between the reviewer and the author usually saves a lot of back and forth for clarifications. It also helps to avoid misunderstandings and even unnecessary emotions due to people's different styles in written communication. Until now, we have only talked about best practices as conventions. In this last part, we will have a look at Git hooks, which enable you to automate and technically enforce certain of these conventions. Git hooks are custom scripts which run at certain points in time during the development process. They are defined by scripts which are placed in the .git/hooks directory of your repo. Indeed, if you set up a new Git repo using the git init command, then some example scripts will automatically be created for you in that directory. There are two types of hooks: client-side and server-side hooks. Client-side hooks run on your machine. By nature, client-side hooks are used for checking things in code changes before these changes are allowed to propagate to a remote repository. There are two client-side hooks which we want to explicitly recommend. The first one is called pre-commit. It enables you to run checks on your repository before a commit. This is the ideal place to run your linters and your tests so that no change can ever reach your repository which is not correctly following code formatting rules or which is breaking tests. Checking these things automatically will offload them from the pull request reviewers and allow those folks to focus on more important things. The second client-side hook, which we recommend, is called commit message. As its name suggests, it enables you to run custom code for checking the format of commit messages. Using the commit message hook, you can easily enforce the commit message guidelines that were mentioned by Lena earlier. Server-side hooks run on the Git server. They can be used to check changes which are pushed to that server and possibly reject them on the basis of certain rules. There are two server-side hooks which we want to highlight. The first one is pre-receive, which can be used to validate changes and reject them from being pushed to the repo if necessary. For example, you could use pre-receive to check that no one is merging their own feature branches to develop, or is using history-changing operations like force pushing on a protected branch, like the master branch. The second server-side hook is post-receive. This hook can be used to react to changes reaching a certain branch. For example, you might want to close a ticket whenever a feature branch is merged to develop. Now, you might be wondering why we are not mentioning any hooks concerning pull requests. Wouldn't it be nice to have something like a pre-pull request hook to attach logic to pull request creation or pull request approval? Indeed, it would, and some Git platforms are offering features in this direction. However, it is important to note that these are platform specific and not part of Git, as are pull requests themselves. This brings us to the end of episode 1 of our GitOps webinar series. Thank you very much for joining. We hope you enjoyed it, and we also hope that you'll join us for episode 2, which will be about infrastructure as code. We will announce this episode shortly on the usual channels, or you can sign up already now using the link on the slide. Now, we are very happy to answer any questions that you might have.
Thanks a lot, Mathis. Thanks a lot, Lena. Great material. We haven't had any questions so far, so we're going to wait a few minutes, a few seconds to see if some of our attendees have a question regarding the topic. I don't think so. I don't see any activity. Well, in that case, we are going to publish, of course, this video on YouTube in the Vision channel, vision.tv, and of course, Bespinian as well will publish it. I don't know exactly what is the name of the channel of your YouTube channel as well, but it will be available in both platforms. And in case you have any questions, I'm pretty sure you can go directly to Mathis and Lena. They will be more than happy to help you in your Git journey. So having said that, there are no questions from the audience. So in that case, I will say, everybody, thank you so much for attending. Thanks, Lena. Thanks, Mathis. It was great content. And see you soon. Remember to sign for the second part of this webinar series. The link is right on the screen right now. We're going to put it as well on our YouTube channels, and we're going to distribute it as well over social media. So that everybody comes back for the second part of the webinar story. Thank you so much. Have a nice evening, and stay tuned for more material. Thank you so much. Bye-bye. And everybody left. There we go. We're going to stop recording.